Hello, my name is Lauren James, and today I'll be presenting a comparison of water quality in an urban stream. To begin, this study was conducted on Waller Creek near the University of Texas at Austin. As a body of water in an urban environment, Waller Creek is exposed to stimuli that differ from those experienced by a rural creek. With a population of 964,254 people and growing, Austin is responsible for introducing high concentrations of chemicals and other pollutants to its green spaces. Furthermore, urbanization increases the number of parking lots, roads, and buildings, all of which prevent rainwater from infiltrating the ground and require special means of drainage. This means that more water flows overland, picking up pollutants before depositing them in streams like Waller Creek. Researchers use water quality indicators to help monitor creek health. The 6 indicators used in this study were nitrates, phosphates, dissolved oxygen, conductivity, pH, and water temperature. Water quality indicators can indicate pollution if their values fall out of the healthy range, but unfortunately, they can't identify specific sources of this pollution. This brings us to the driving question for this study, which is there a relationship between water quality and location by comparing 2 areas along Waller Creek near the University of Texas at Austin? A bit more background information on this study. It was conducted with multiple groups across multiple locations on campus along Waller Creek, but within the study specifically, there's a comparison between only 2 of the locations, being Clark Fields and the Alumni Center. With this in mind, a primary hypothesis was devised, which was the sites are significantly different between the indicators being compared, and if this was true, a secondary hypothesis would be one location will be worse than the other based on a comparison to the range of healthy values for these indicators. I'm going to briefly go over the materials used for this study. In the image to the left, there are 2 instruments, the one on the top being the YSI multiprobe. It measures pH, water temperature, and conductivity. The instrument on the bottom is V1000 photometer, which measures dissolved oxygen, nitrates, and phosphates. In addition to these, in the initial water sampling, some safety precautions that we took included wearing gloves, appropriate footwear, protective clothes to ward against poison ivy, and used a lot of hand sanitizer because of the pollutants and bacteria that were found there in the creek. As I stated before, water sampling was performed at multiple locations. These properties and others were all measured, and the data was compiled in a large community spreadsheet. By having multiple properties to compare, the data analysis specific to this research involved gathering all the data points for each property and organizing them so they could be analyzed in a separate spreadsheet. Here we can see how the data was organized once by property and again by location. The number of data points for each property was uneven between locations. Because of this, data analysis included 2 sample t-tests assuming unequal variance. Here we can see the results of the t-tests. All of the water quality properties, excluding nitrates, show to be statistically different between the 2 locations. This is consistent with the initial hypothesis. Because the initial hypothesis held, the next step was to compare the properties to expected ranges of healthy values as seen in the far right column. An average was taken of each property at both locations and compared. As indicated by the red highlighting, phosphates and conductivity were outside the healthy range in both locations. In addition to this, the pH at the Alumni Center was slightly basic and was therefore marked as cautionary by the yellow highlighting. I'd like to note that the reliability of this data could have been affected by the accuracy of the measuring instruments, human error operating said instruments, and by the different sample sizes for the two locations. Now I'd like to transition into the discussion portion of this presentation. In relation to the results of this study, the high levels of phosphates could be as a result of industrial runoff, human and animal waste, and some cleaning products. In addition to this, high conductance could be attributed to a combination of industrial runoff, extended periods of low water flow, and the limestone that is characteristic of the Austin area. Moving forward, in order to address the second hypothesis, more research would have to be performed in order to confidently deem one location as unhealthier than the other. In addition, attention would need to be paid to the accuracy of the data and the sample range should be increased. Outside factors like time of day and weather should be as similar as possible between the two sites. How can these results be useful in the future? The results of this study would be useful to pinpoint where certain pollutants are entering the water at locations that consistently present unhealthy conditions. From there, researchers can begin a dialogue with the City of Austin regarding the changes and repairs that can be done along the creek. For example, if a leaky pipe from a nearby building was introducing harmful bacteria and pollutants to the water, it should be repaired. Unfortunately, some sources of pollution are not as straightforward when being identified and can be a result of a combination of factors. In addition to these combination of factors, they can also be a result of changes in nature, such as time of year and rainfall. Because of this, it's better to be proactive instead of reactive if the source of pollution is not obvious. Some ways to improve creek health and limit the introduction of additional pollutants would include educating the public. We can do this by encouraging people to clean up after their pets, avoid disposing of their chemicals outside, and limiting how much fertilizer they put on their lawns. This would minimize how many chemicals and pollutants are washed into the creek. Another way we can improve creek health and limit the introduction of additional pollutants would be by limiting places where these pollutants can enter. This would include improving riparian zones or places around the creek by planting vegetation and creating less impervious cover like parking garages, buildings, and sidewalks. This would mean less erosion and runoff, and pollutants and other chemicals can filter through the ground naturally instead of entering the creek. In conclusion, it was found that between the two locations, they exhibited statistically different values for 5 of the 6 water properties that were compared. They also exhibited unhealthy levels for some properties based on a comparison to known healthy values. Unfortunately, there was not enough data to determine which one was unhealthiest, and more research would need to be conducted to do so.